Hello, good morning. I'm pleased to see so many of you here. I mean, it's Friday, it's morning, it's Friday 13th. There was great parties yesterday, and still the first session I see so many faces. I guess it's because you're intrigued by the title, right? It's about Go, it's about Java, so how they two correlate, can one learn from one language to another and how it works. So before we start, two quick announcements. First, I kind of like recovered from flu recently, so my voice might still not be of the usual sound, so sorry for that. Second thing, it's actually my first visit to an English-speaking country, so my apologies if I mispronounce or misspell something. And now I guess you have questions, right? You sit here, have questions, and the very first question you ask yourself is, what the heck is this guy's name? Right, so my first name is Piotr, my second name or my family name is Przybyl. Apparently Y in Polish is a vowel. So let's go. Who am I? This is my Twitter nickname. I title myself as a software gardener. If you don't know who software gardener is, I encourage you to read the fantastic book called Pragmatic Programmer. I also work as a trainer from time to time. I earn for a living at a great startup, great company called Atomic Jar, right? We are about test containers and beyond. And from time to time, I post some stuff on my personal blog page, which is softwaregarden.dev. Okay, yeah, so this is me. Even when I go on holiday, we went on holiday to Spain a few years ago. Java, you see, is somewhere in my background, right? So this is actually me, right, over the years. So the question is, who are you? Who of you are JVM developers in general? Okay, Java. Okay, majority, or vast majority. Kotlin. Yeah, okay, both hands, very nice. Scala, perhaps. Okay, some front-end people, TypeScript, JavaScript. Okay, anybody else? Any other paradigm? No, okay, one person who prefers voting with the left hand, right hand. Okay, so you are Java people, or JVM people, as I was a year ago, right? A little warning, caveat auditoris. This talk may contain mistakes, as every other talk, in fact. So it's a human thing to make mistakes. Apologies. Don't trust anyone. Verify on your own, right? So this talk is not a crash course of Go. If you came here with the hopes that you will leave the room after 50 minutes and you'll be able to, efficiently program and Go, I'd rather prefer to disappoint you right now, right after than the whole hour, because it's not crash course of Go. What is this? This is roughly a talk describing my my journey learning Go over like almost a year, right? Being a Java developer previously. So it's about what I found intriguing in Go, what I found annoying in Go, what I can share with you, and what I think now, but my thoughts and opinions might change in the future, right? So basically, this talk is about like, if I were able to meet myself a year ago, this is what I would have told myself, right? So this is about that. Okay. Yeah, and I can actually make mistakes in Go, right? I do mistakes in any language. Go is not like immune to that. Okay. Well, the thing is, I'm not like totally quite Java developer, right? So my first programming language, I started to program in C++ with the structures and whatnot, right? So it was this kind of procedural programming, if you call it that way. Then I earned for living with PHP 3. I mean, many people earn for living even these days with PHP, and there's nothing bad about that. It's just to tell you my story, right? I enjoyed programming pure C on, and I mean the System 5 style, right? So the Unix, pipes, signals, and everything. No exceptions. I like that very much. I did some stuff in Scala with my life, and then I did even some JavaScript, Python, C#, OCaml, and other languages, right? So I kind of knew a few paradigms before, and so on. So recent story of my life is more or less like this. New job happens, right? Because Atomic Job, explodes, right? And it's a great thing. So then I discover, right, and discovered in the repositories that they also use Go, that we also use Go. It's like part of our ecosystem, like our toolset or whatever we call it. And it looks like C-ish, right? So it has these ifs, it has for loops. You can see interface here and there, right? So how hard can it be, right? Wrong. It can be hard, really. If you assume that Go is just another C-based language, please stop doing that, right? I think it is not, right? It has the keywords, but the mindset is kind of like different what I've seen in other C-derived languages, so to say. So things Go shares with Java are the following. They work. They do fantastic work in production, in testing, and everywhere. So that's really, if you think like if it's like I don't know, inferior language or something, please stop doing that. It's like really cool language, and with a rich ecosystem, you can do a lot of things, right? They use C-based keywords, like I said. They are both about static typing, right? And they have type inference. They are compiled languages, meaning they are not interpreted like during execution, just before execution, right? They have to compile it, both of them, and then you have this artifact you have to run, right? And they both have garbage collectors, right? And they give you a memory safety, and they both have interfaces, and they pass arguments by value, right? So this is like the common thing. Things which are different are these. There's no virtual machine in Go, right? So you compile to like native artifacts, and it has to be supporting this operating system, this architecture of the CPU, and the like. There are structures or structs. There are no objects in Go. Therefore, Go is no OOP. There is no inheritance as we know it from Java or other like languages like C++. Dependency management is different, so there is no pom.xml file or Gradle file, right? They are just managed in a different way. There are pointers, right? So apparently pointers didn't add up with C++. Concurrency model is different, at least these days, or maybe it changes because Loom got merged last week, if I'm not mistaken. There are no exceptions in Golang. Interfaces work different way, and yeah, generics, they were added into the last release of Go. This talk is not about generics, but they also like work in a different way, right? So this talk is like divided into pro tips. I'm going to give you some tips, and hopefully you'll be able to apply them, all right, to give you like to show you what are the most important differences, I think. So the first pro tip is when searching for Go, many times just search for Golang. I mean, it's okay. We know the story. It's it's a gift that keeps giving, like that joke, right? So the search engine company created a language and they named it Go, right? And then good luck trying to find anything related to Go. Like that's why many pages say like Golang, or Stack Overflow questions about Golang and so on. So if you have no luck finding something related to Go, like how do I do something in Go? Try doing something in Golang. Maybe that would help. It helped me a lot, I guess. Another pro tip is this. I mean, it applies to learning process in general in many things. Like this is how we humans absorb knowledge, right? So we know something. It's like the foundation for the next thing we want to learn, right? And in terms of Go, if you're like heavily used to Java, maybe it's better to forget about Java and just try to learn programming from scratch, ab novo, so to say, right? Because like, okay, like there's a concept of variable, like some loops, conditionals, but beside that, it might be different, right? So yeah, this is before learning Go. One thing, I want to show you one thing. By the way, the slides are online, the code is online, right? So there will be links at the end. So this is one of the things, right? How do you format time in Java, in JavaScript, and in many languages, right? You go here and we specify this age, SS, or date, and we always confuse whether it's capital M or lowercase m, right, for minutes and months, and you know the drill, right? So in Golang, they decided to go a different way. There is a magic date, magic point of time, selected, and this is what you use it for layout, right? A very specific point in time. And if you want to like do it the American way, you just have to swap the O2 with O1, basically, right? To have it the different way, or change, or use the name of the month and so on, like this precise month, which was January. So this is how it works. Like, see, there's a total, like if you're looking for a kind of like regex or something, this might be also different. Yeah, so keep your mind empty and be eager to learn. Another pro tip, and if you have any questions, just raise your hand, wave, like interrupt, right? There's a thing called Go Playground, and it works like this, right? Oh, let me zoom in. See, it's maybe I'll show you the, yeah, it has this GoDev like play. You can share the link with someone if you're asking questions, Stack Overflow or something, and then you can select the, like it runs in the internet, right? It always runs at the beginning of the time, and you can write your Go program. You can then click format, so it will get nicely formatted, and then you hit run, and it will run, and you will see, welcome to Go Java developer, because this is what we wanted to achieve, right? And then you can share, like send the link to somebody else. So if you want to experiment with Go, you don't even have to install anything on your machine. Another thing, it's the native executable. So unlike these VM languages like Java, like we have jars, we used to have wars or wars and ERs in the good old days. There is no like concept also of dependencies, like something is loaded. Like you create one file on Windows, this would be this one.exe artifact, and this is what you deliver, right? So this is the thing that's going to run. So there's not going to be like a dynamic loading in Go itself and something. If you let's say a library that's using something else, right? Okay, and this may rely on the like .so libraries on like in Linux or Unix or DLS in Windows, right? But the program itself, it just has no concept of like class path. So you can like end up with the class path hell, you know, changing the order or something like this. It doesn't exist in Go. So this is how it works, right? There's a different paradigm. And this looks like kind of similar to Graal, I would say, right? So we just end up with a single native thingy, we double click it or we execute it from CLI and it works. Okay, another pro tip, type inference is very common in Go. It looks similar to var in Java, right? Since Java 9, only there's more, I would say. So as you can see, well, first we initialize some seed for random, and then like this would be the Java thing, like var is like it's going to be variable, right? This is the name, random number 1. Go is very like about having short names, really short names, and then you could put the type, right? The thing is, nobody does that, really, in Go. So sometimes you see this var random number, and then the type is inferred because it's an integer. And what you actually see a lot is this thing, right? So we instantiate or declare the variable and also assign a value, and therefore the type is inferred, and we have this Pascal-like assign operator, right? So this is how it works in Go. So there is no magic. So when you see this, it's actually more like this in Java. And if you want to declare the types explicitly, you don't go with the type in front of the name. The type follows, right? This is how it works in Go. Another thing. Functions in Go can return multiple values. Like in Java, we can return only one value. So therefore, we use some hacks, right, to bypass that. We use like arrays or create these beans or records, right? In Go, function can return multiple values, and all of them have to be consumed or ignored, else the code won't even compile. Right? If you don't consume a variable, then you have to explicitly ignore it. You can't have a variable dangling somewhere out there. And it might look similar to, like, for example, the tuples from Waiver, or like with the records in new modern Java, right? So if you want to like return many things, you can instantiate or declare a record, right, next to that method, and just return the record. So this is how it looks in Go. I can show you like in the code that I'm not lying. See, so this is it. So we declare a function with like name, full name, and we declare that it will return two strings, right? One string and two string, and this is how we do that. We just return John and though. Of course, you've noticed there is no semicolons, right? And this is how we call it. We just assign the first value and the second value, and we welcome this this person. The code should run. Yes, it does. See, so welcome John Doe. And if I were, for example, interested only in the first name, then if I just get rid of it here, as you can see, then it starts to fail because this is not consumed. Then I have to go with underscore, and then it just says hello, John, right? So this is how it works in Go. You either consume everything or you ignore everything. Like not everything, the thing you don't need, you don't use. Another pro tip. Go is very idiomatic, right? So for me, when I started to learn English as a teenager, it was overwhelming sometimes how many idioms there are in English, right? So for example, kick the bucket, right? And I wish none of us kicks the bucket anytime soon, but you know what it means, right? But literally, what does it mean to kick a bucket, right? So in Polish, we kick the calendar. It's another idiom, right? So, and you see, this is the thing. So in languages, there are different idioms meaning exactly the same. So you want to achieve something, but you express your desire in a different way. So if you think in Java, right, in Java's way, then you think about kicking the bucket, right? Whereas in Go, this would be kicking the calendar, or opposite, or something else, right? I should have picked another example. I mean, this is not very nice, but it tells you the story, right? So in Go, there are idioms. There is OK idiom. There is done idiom, right? So whenever you see like an answer on a Stack Overflow, you just follow the done idiom. You just like think if like, I don't know, like tokens or parts of the source code you have to pass, or like a design pattern maybe you have to follow, something like this, right? So you see there is this, maybe I'll show it yeah, I can zoom the screen. I mean, make the letters bigger. So let's say you find the users by their UID, right? And sometimes you can find such user, or sometimes this user doesn't exist, right? So we don't use like optional here. We don't use the null to indicate there was no such user because we have two values. So this is how it works. And this is by convention that the last thing is going to be Boolean returning OK. Right, so if there's UID1, a UID1, then we go and return John Doe and found and Susan Doe, and if we didn't found the user, we just return whatever and false. Right, these are the default values, basically. So when I run this thing, see, I welcome John Doe. Now let's try to run it again. I'll run the previous example, this thing, John Doe, I don't know if they run, okay, see, and this is like user 0 unknown. So we test if this last thing is okay, and by convention it's named okay, right? And if okay, then we just handle the user. If it's not okay, then we know that things are not okay, and this is basically rubbish, and we can't rely on this, right? So there is, as you can see, no optional, no null. In this scenario, we just go or follow the okay idiom. Another pro tip, there are no exceptions in Go. I know this is shocking for many people. I used to program like in pure C, so for me the lack of exceptions is not such a big deal. But there are people making jokes about this, that the Go is actually like if nil, right? There's someone to even have like a, I don't know, a keyboard with these words attached, so to say. So again, by the convention, the error has to be returned as the last value if there is an error. And this is the opposite of the either fashion, right? Because in either we have the right thing as the second thing, or the last thing because it's the right thing, right? And the left is what's left if that's an error, right? It's the opposite in Go. So the error goes as the last value by convention, by the idiom, right? So we have string, and error. If we just want to, like, if okay or not okay is not enough, you want to return an error. Like, what's the reason, for example? So as you can see, we can go for no such user, or let's say that the 0 is incorrect UID. Then we return explicitly that this was incorrect ID. All right, an error. This is how we create an error, like one of the examples of creating an error. Then there is nil means there is no error or no nothing. And here again, and this is basically working the same way. And then you can check for the error. Like previously we checked for OK, now we check for an error. So if the error is nil, then it means we got the user back, so we can welcome this person, right? And if there was an error, we just can say, like, for example, this is an error and this is the UID that we wanted to ask for, okay? So again, like idioms. Another pro tip. If lack of exceptions wasn't enough, there are no objects and there is no inheritance in Golang. They don't exist in the way we know it, we think about them. There is no implements keyword in Go, but we can implement interface implicitly because there is a concept or notion of interfaces in Go, right? But they work maybe not totally different, but very, very much not like in Java, I would say. So let's go for this another code sample. Let's see if it works. I mean, it should work. Okay. Yeah, incorrect UID. It's a very nice. Yeah, it didn't work. Okay. So I think you recognize this code. This is the code that we saw in the previous example, right? Again, we return errors, so we expect to follow this idiom. It's just we want to have a custom error, right? So we created a structure, and this structure has this UID. So we're going to, like an exception, you wanted to pass like the incorrect UID, for example. So we have a structure having this UID as an integer, and then we create a method. This is how we create a method in Go, right? So this is a function. Again, it has before the name, it's like has the type declared and like alias for this thing is going to be called on. Think of it like this. Basically, right? So this is going to be the Java this. So this is the difference between function and method in Go, right? So the method have extra this, like the target on which they're going to be called, instead of passing this as an argument. And we have this wonderful function, method, which will be called on this incorrect UID struct with the name of error, and it will return string. And because of that, I mean, if I name it, for example, error2, the code stops to compile, right? Because it says incorrect UID is not an error. So if it walks like a duck and quacks like a duck, it's a duck, right? But it's not dynamic thing. It's checked during the compilation, okay? So if I happen to have any type and it has a method declared that is named error and will return a string, it means it's an error, right? Then it's basically this, meaning this type, this incorrect UID kind of like implements the error, right? And because of that, I can just return incorrect UID here instead of like using this very basic errors new. So this is how it works in Go, right? So there is, as you can see, there's no interface in here. There is no implements in here. The interface might be in here, see? So the error is the interface, and it's like the expected signature, right? And you can have more methods. You can implement more interfaces implicitly this way, but this is how we do that in Go, right? So as you can see, this is the interface. So it doesn't say struct, it's this type interface, right? This method has to be there, and so we implement this method in this type, therefore it's an error, and therefore the code compiles and works, even if you don't have this UID, see, because we then check like if we print the error, right, and we check what the error is, and if it's the incorrect UID, then we can format it as incorrect UID. Like, so this is like the kind of like instance of equivalent, and we don't use it often in Go. We use it mostly just for checking errors, I would say. If you have a need to go for instance of with anything else than an error, then I would say it's a code smell. Alrighty. Another pro tip for us. You know this constant debate whether inherit or compose things, right? And some people say that inheritance is always bad. I'm not in that camp. I would say that inheritance is for inheriting things and composition is for composing things. And it's just important to know which is which, basically. So it's not that inheritance is always bad, I would say. It's overused because it seems to be easier. That's the reality, I would say. Nevertheless, in Go, we can inherit by composition. Let me show you how it works. And this is a very nice concept, and I truly miss it in Java. So we have this type of swimmer, right? The swimmer is going to swim in a certain style, right? Think of it, yeah, this is a struct, right? And we create a method for this structure, so the swimmer is going to swim in this style. So good so far? Cool. Then we have the runner, and the runner again has its own style, so it's going to run in a certain style, right? So again, the runner is running in a certain style. So then we can have a new structure, hippo, and the hippos, as you may know, are both swimmers and runners, right? And instead of creating this, like, I don't know, as swimmer and R runner, I just skip the names like this, and I just say hippo is kind of like swimmer and runner inside, okay? And then when I run this thing, I can create a new hippo, being a slow swimmer, but quite excellent runner, if you don't know it. Some say that more people in Africa are killed by hippos than by crocodiles, because they are so damn fast. Anyway, this is pretty obvious, I would say, right? So inside hippo structure, we have swimmer structure and runner structure. Therefore, you can access them by this dot notation, okay? So from the hippo, I access the swimmer and I tell swim. And in a similar fashion, I access the runner and I make him or make her or make this hippo run, right? And this is like pretty Java way, I would say. If you have a thing like an object inside, you can call a method on this object inside. I mean, okay, it's not nice. I mean, you know, it's against the code of clean code, right? And it's like the law of the meter and whatnot and whatnot. That's true, but technically it works, right? And how about this? Let me run this code so that I'm not cheating. As you can see, if I just include, without using any name, if I compose the swimmer and runner in hippo, it means that hippo itself is also a swimmer and a runner, and I can call these methods directly on hippo. So this means that the hippo, via composition, can kind of like inherit the swim and run methods, right? And then if you think about it, it's very, very nice concept. I like it very much, right? So this is how if you ask how do I inherit in Java, you don't. Sorry, in Go, you don't. You just compose stuff up. Another pro tip: methods and functions can't be overloaded. You have a question? Okay, sorry. I haven't noticed.
Hi, yeah. With regards to the previous one, does this work just in the same file, or you can do this cross files? So I could create hippo in one file and then
Yes. We'll get to that, what's public and what's private. And this very example is a single file. If you wanted to chop it into like different files, then we will have to make this style capital S, but we'll get to that, okay?
Cool.
Yeah, but it's like, I guess maybe this might be like Scala related or something like this, that the traits have to be in the same, yeah, okay. No, there's no such restriction, at least I'm not aware of it. Okay, right? Because you can compose types from, and this is like frequent, okay? So, for example, you have this reader and closer. So thing can be a reader and closer. So it reads things and then closes the thing, right? And of course, reader and closer, they are defined in a standard Go library, right? And you make your own thing, for example, that you can compose stuff like this and so on. Another question, yes, please.
What would happen if these both objects, swimmer and runner, maybe have a function called do sports or stuff like that, but with the same name?
Oh,
okay. Would take them?
So the question is basically, if I'm not mistaken, diamond problem, right? So we still have some time left. Let's see. Let's call it. Let's go with just like do sports or do sports in runner and do sports here. Do sports here, right? And we are not interested in, okay, maybe we can do that, like do sports, this works, and this doesn't compile, right? It says ambiguous reference to sports, right? So this is like the methods in the default methods in Java interfaces. If you have a name clash, you have to be explicit about which interface you're going to call, right? Similar here. See, there is no diamond problem, I would say. Okay. What did it like file changes? Okay. Another example, another pro tip. Yeah, so methods and functions cannot be overloaded. Yeah, it would be seen in IDE as well, right? Maybe I will just explain you what's this thing about. So the philosophy of Go is this. This should be a language, easy to learn. Like you look at it, you understand the meaning, like you match the idioms, right? But it also should be a language like machine friendly, right? So it's very efficient and so on. It compiles fast, runs fast, and so on. So it's like above two worlds. And apparently creators of Go decided or made the decision, or they just thought that overloading methods like we know in Java, so we have a method with a name, and then you have 2 parameters, 3 parameters, 78 parameters, and so the story goes, right? They decided it's not a good way to do, and therefore if you have two functions or methods with a similar name and different set of parameters, it won't work. It basically won't work. See, if I try to name it do again, and in Java this would be a very nice code, right? Because I can do thing like with a nothing, because there was nothing, and I can do this thing that was passed, right? This is overloading. It doesn't work in Go, again, because this method is already declared. So meaning like this name was used, and therefore it's no Go, so to say. Yep, another pro tip for you, access modifiers, right? So where is the public, where is the private, where is the protected? Or even in Scala, we have, I love Scala's sophisticated access modifiers, right? So you can make thing private this, so only this object will be able to access it, not the other object, even if it's of the same class, right? Or trait. It won't work, right? In Go, again, Go should be easy to learn, to comprehend, to reason about. So the rule is quite simple. There are no access modifiers. And blocking access from, like, for example, from the outside file, from the another package, right, is still possible. And it works like this. We are in the utils package. I mean, we shouldn't have packages named utils, right? But in reality, sad reality, we know that there's always this, I don't know, string utils or something that has to fit somewhere, and there's this like varia utils package. Okay, and we have this thing which is accessible, and this thing is inaccessible. And it's not because Go is very clever when it comes to reading English, right? It's just this is uppercase letter, and this is a lowercase letter, meaning if it's uppercase, I kind of like to shout it to everyone else, to the world, and then it means everyone else can like access it. And even in this very matter, override it, right? This thing, it's inaccessible because it's quiet, right? It's lowercase. Okay, so then if you try to access it from main, this is accessible and this is inaccessible, right? If you try to uncomment this, then it won't compile, and of course calling say hi will work. Let's see if it works. I mean, stop talking and show me the code, right? As you can see, say hi works, and say hi can access both things because it's declared in the same package, right? And if it was declared in another package, it wouldn't have worked. Okay, another pro tip. Yeah, I saw square brackets beside fors and ifs. I saw also square brackets. I saw arrays. How foolish of me, right? So make sure what you see is an array in the first place, because it might be a slice, not an array. We'll go and cover slices in the next pro tip. So arrays in Go aren't like arrays in Java. Right? They share the name and square brackets, and that's it. Arrays are values, right? So how does array work in Java? We have a reference, right, or pointer, just a reference, right, and it just references this structure in memory, all right, and this is how it works. And when you pass an array, you pass the pointer and so on. Arrays in Go are values, pretty much like primitive types we have in Java. And this like kind of brings us into Valhalla reasoning, right? So Valhalla is also about this. So with the like objects are going to kind of like, excuse my French, lose their header, right? And then it means that they will be treated like a primitives, right? So it's just like, this is not exactly this, but this is like this way of thinking to point you in the direction to the like the nearest thing in I know in Java, right? So these are the arrays. Okay, let's go to IDE. That's better, I guess. These are the arrays in Golang. Sorry, and I have this function called print A3, and it's not going to be that sheet of paper. It's just I'm going to print an array of 3 elements, right? That's a hint for you, right? And this is S3, and it's an array of 3 elements, of 3 string elements, right? And this is how I can create an array in Go, okay? And then I can print it. Let me just run it, okay? Yeah, should be perfect, right? And this is another way. If I like don't know how many I will have during the when creating the array, I can just use ... and again it's an array of 3 elements. And I can create a copy of this array, right? This is called array BSC, this operator, right? And then I replace the first element in A3 bis, right? And as you can see, it didn't replace in both copies, right? So this is like a value, right? So it got copied. So I replaced only the first element. This is like proving you that the arrays are values, basically, right? And this thing won't work. Why? It's because A3 has already assigned type of being an array of 3 elements. So the size of an array is part of the type of that array in Go. Right? So it's not array of strings, it's array of 3 strings. That's the type, that's the exact type. Therefore, I can't create suddenly or assign an array of 4 elements to that variable, which is of type or of array of 3 strings, not 4, right? Therefore, you see, it's like you have an integer. When you have an integer, you can't suddenly assign, I don't know, bool to it, okay? We can assign, I don't know, too long, we can assign int in Java because, you know, it will be like upper type, I mean, the ranges and whatnot, you know the drill, right? But this is not how you can assign various types in Java as well, right? Therefore, this won't work as well. I mean, this will work, but then it says this variable is not consumed, and when I try to consume it with this function, it won't work because this function expects array of 3 strings, and I'm passing array of 4 strings. See, arrays are values. They are not like what we have in Java. So what you might be after, actually, okay, whatever, is slices. Slices are kind of like wrappers around pointers and arrays in Golang. They are size independent and append friendly, meaning this is like an array in like you can attach values and so on, like think array list, something like this. I think it might be the closest friend in Java world. And thing is, append works very nice in this demo you copy. And then in production, it might not work, right? Because how append works is heavily context dependent, and it actually boils down to pointers. And this might get you in trouble if you're not aware of this. And let me show you what's the actual reason for this. Okay. So, a very similar method, right? This time we're going to print slice, and as you can see, for printing slice, I don't have the size declared. Right? So this tells us it's a slice, it's not an array. And then it's another idiom, so this is like the for each loop in Golang, and this thing is the index, this is the element, okay? And since I'm not interested in index, I ignore it, so this is again an idiom, like this is the for each loop over and slice in Golang. This is how you do that. Okay, and then it's just an empty line. And I create a slice of 3 elements, and I print it, and I create another slice. Sorry, to the same slice, I again create another 3 elements, right? Slice, and then let me just run it. Yes. Okay, so this is like no surprise so far, I believe, for you. Okay, and then we create another slice, being a copy of this, and to the first element we assign a new value, and then will it print after replacing? It prints like what we have expected with arrays, perhaps in the previous step, right? So it prints the dd as the first element. Okay. And then how will the appending work? Okay, so to the second slice, the S piece, we append G, one element. This means that this slice will look like this, and that's again expected. Okay, and then we replace again the first element to be like not the uppercase DD, but just as it was before, single D. And then it gets replaced only in the appended one, in this one, and not the original one. What has happened? Slices are not arrays, right? Again, and this is how it works. They are like pointers to a structure which keeps an array inside and has two properties: the capacity and the length of the whole thing, right? So it just can show, like when you append an element to a slice and it still has room in this underlying structure, then it will append it. Just add like to another array cell or whatever it's called, right? Another index. But when it's full, it will just like an array list create another one. And this is just how it worked with this copying, right? So when I copied here, here, right? It wasn't copied totally, it was just a copy of the pointer. So I had two pointers pointing to the same thing. And then when I called append from one of them, then there had to be a new array. So the one of the pointers started pointing another array, and we appended to this other array. So we had then these two pointers stopped pointing at the same backing array. And therefore, when I replaced the first element, it replaced it only in this second array. That was replaced because of appending. This is how it works, right? See, it gets back to pointers and so on. So when you happen to have a slice of 100 elements, right, and you copy this slice and you start appending, like here and there, it will work very, very nice until you reach this moment of 100 elements, right? And then magic will start. I mean, magic. Scratching head. What's the reason for the error, right? In the code. So this is why. So like append and slices are not what we are used to from Java world. Question.
Yeah, sorry, just a question about the arrays. Can you use a dynamic number for the size, a bit like in a vector in a dependency type language like Coq or Idris?
No, in Go. Like
okay.
The size of array is part of array's type. So array of 2 strings and array of 3 strings are 2 different arrays by type definition. Therefore, it can't be like dynamic in this matter.
What I mean is that you would say n, for instance. So you have a method. So for instance, you could define append is a method that takes an array of size n and returns an array of size n plus 1. So this is called like dependent type of
I mean, this is what happens under the hood for slices, right? I mean, so it creates the bigger one, and it's growing dynamically. This is like exactly this, I guess, right? So else it wouldn't have worked. So it doesn't have to be 3 like with these 3 dots. It just counted the thing. Yeah. Okay. Another pro tip: use Go FMT. It's really beautiful piece of I mean, indentation, 2 spaces, 4 spaces, 8 spaces, 3.5. Exactly. They don't have that problem in Golang. I'll show you how it works. This is how it works. Whoops, sorry. Wrong key. So yeah, I can smash enter here and enter here, and let's see if the formatting will work. Yeah, it worked, but I use enters, right? But when I go for, let me just remove this, and let's change the indentation here and indentation here, and then I just format it, and it goes back into this shape, right? And this is beautiful. I really love it because it ends this nonsense, this rubbish, this never-ending disputes whether we should use 4 spaces or 2 spaces, right? So there's no method overloading in Go, and there is like one strictly defined way of formatting code. Beautiful, because we don't have to argue about it, and it works in IDE as well, right? So I don't know, if I added here spaces and here spaces and change the indentation, and then I should be able to call the what was the command exactly? You know, the demo goats and something. It already got fixed by the IDE because it applied it. Sorry. Yeah, see, the demo goats aren't with us. But this is how you do that, right? You go just from the root directory. It basically it tells Go. It should have like Go in the front, right? Go, and it says, just format the whole source tree for me, right? So there is one format for this, and if you don't happen to use that, just use spotless, right? And in Java, you can have the same effect. So you just call it, you can hook it into your Maven or Gradle and format the code in the same fashion. So there is no ongoing debate. Okay, a few minutes left and 2 pro tips for you. Pro tip 15. As we know, threads might be, I mean, in the beginning, there were processes, right? And then we discovered that processes might be too heavy, right? So we went for threads. And then we followed happily the thread per request paradigm, right? And when discovered that threads are too heavy, right? So we have reactive, we have Loom now, and so on. And sometimes we might want to go for something lighter. So we have the coroutines in Kotlin, right? And in Go, we have the Go routines. Yeah, and this is a very nice explanation for you why Go routines are not lightweight threads, right? So the Go routines are basically Go routines. And this is like, we have the same issue in Java, and therefore we're going to have Project Loom, right, as a preview feature of Java 19 coming this September, right? So we are trying to tackle the same issue, and the Go has decided to go for Go routines for that. So this is how it works, right? So I have this print string function. It will print me the string 100 times. So this looks quite familiar, right? Yeah. So, but anyway, and this is how we do that in Go. So we have one Go routine and another Go routine. And how do I do that? Is just I put Go in the name of the function, right? And this means it will be called in its own Go routine. And here, just to make sure that we see hi 100 times and hello both also 100 times, we have to create this wait group. Again, one of the idioms. We could have done this using the done channel, which is the done idiom then, right? So we defer saying that I'm done and saying I'm done. So this is like the finally kind of way of doing things for Go routines. Yeah, and when we run it, I'm not going to count 200 lines with you. We just assume, yeah, the hi was printed with 99 and hello was printed 99 times. And this time they didn't overlap, it seems. Yeah, but like just like with the threading, it has yeah, this time it see they interlapped or intertwined each other. Yeah, so there is no threading as such in Go. There are Go routines. And last pro tip: down calls to C are quite simple, just as they're going to be in Panama, I believe. I mean, I've seen Panama in Java 18, and it works really nice when you have to call the native stuff in C. And calling native C in Go is also not complicated. Let me show how it works. It's kind of like weird thing. It's not the best thing, and I kind of like don't like it because you have a comment, right? You have a comment. In this comment, you happen to have C code. And it's nicely colored by IDE because JetBrains folks did a great job and they coloring this as if it was C, right? But normally we'll just see a comment. And you toss import C on top of it. And this, as you can see, this is like a syscall. It works at least on Linux, telling me that this is like the name of the thread, or the thread IDE, right? And then I import it as this fake C package, right? And then I can create, in this loop, I can create this C string, this greeting being C string 100 times, and then I can call this greet function using this C string. And let's see if it works. Yeah, it works. It works just that fast, you see, because it's even C. So as you can see, this Go routine was called from thread with this ID, and the other were another ID, right? So this is how it works. So as you can see, if you have to cooperate with C or call something with call some C from Go, it's a no-brainer, really. It gets difficult when you have so-called upper calls. Right, so we want to pass like a pointer to a function, so C will call your Go code. That's more challenging. Yeah, but we are going to have something like this in Java, working in a different way, but the effect is the same, and the thing is Panama, right, of Java 18. Yeah, this was the demo. If you got hungry, if you like to learn more about Go, and I encourage you to do, because every time you speak another language, you're like a newborn human, right? And it applies not only to human languages, I guess. Then I recommend Learning Go by John Bodnar. There is a very nice series of talks or articles from Dave Cheney, Practical Go. There's Go by Example. There is this Just for Fun. It's kind of like oldish Java, YouTube channel, but you can still watch it and smash that button. Takeaways for you: unlearn, learn, test. Don't forget about testing, right? And grow your brain. And by the way, we also support, there's a thing called Test Containers Go, right? So test containers are not only about Java, there's also test containers for Go, so you can run your integration tests with Go as well. Experiment, have lots of fun. I had really tons of fun learning Go, but I also happened to have like a friend showing me or pointing like, this is the idiom you should have used, right? Enjoy boring and machine-friendly language, right? If nil, it can get to your nerves, right? Like, it's sometimes annoying, but it's like boring and machine-friendly. And appreciate both Go and Java and other languages too. And I encourage you to always, not just for this session, for every session, every conference, provide your feedback to the speakers, to the organizers. Since we see each other, I can even accept feedback in a paper form. If you got hungry, not about Go, but test containers, Kevin is going to have a session, this mini lab in this cafe area about test containers. Should you have any questions, we'll be happy to answer them. Thank you very much for this, Go Java developers, and these are the slides and everything inside for you. Thank you very much. Have a nice day.